My name is Patrick Barton,
I'm Mackenzie Harpine.
And I'm Rebecca High.
and our mentor was Dr. Lau. And through her class, we learned the assessment of Crab Creek and the effect of the railroad system. For the first slide, we have internet connection and CWA. The three components to stream health integrity are chemical, physical, and biological factors. Stream ecological theory is a study of those aquatic species and their interactions with all water systems. The CWA was established in 1948 and was first called the Federal Water Pollution Control Act, and it expanded in 1972, becoming the Clean Water Act. The CWA allows the government to measure all waterways to be able to tell if they are healthy or not. The CWA and interconnection are very similar because it takes the data from chemical, physical, and biological factors to determine if the stream is impaired or not. Stream monitoring program, we looked at the ecological state of our streams, such as our streams' ecological health and integrity. Ecological integrity is defined as the ability to support and maintain a community of organisms that has species, composition, diversity, function within a region. We assessed the water quality data. We looked at biota. We looked at habitat surrounding the stream and how it can affect health. In this program, in our opinion, it was more in common with all the tasks that we picked, and that's why we picked it. We used all the elements such as chemical, physical, and biological factors that were able to find if the creek can be maintained or not. For chemical, we looked at water quality, such as pH, temperature, conductivity, and more. Physical, we looked at depth, channel units, land use, and discharge. For biological, we looked at things such as invertebrates that we found to start our project.
So for our stream reach characteristics, our stream was in the outskirts of Christiansburg, and it was actually in a neighborhood. So the right side, there was a railroad track, and it's still in use. In fact, when we were doing the stream assessment, a train went by, I think like 2 or 3 times. Then on the left side, there were houses, and the part of the stream that we assessed was along 3 or 4 houses. The widest part of the stream was 6.1 meters, and the smallest part of the stream we assessed was 3.1 meters. So this is a table that summarizes the weather at our stream. And as you can see, the weather was really nice today that we did our stream assessment. Not super windy, and there was a light breeze. As you can see, the crosswinds were 0 and the headwind was -1. The chill was 24 degrees Celsius. So the water was really cold. Luckily, we had waders. The water and the air temperature were actually the same. So this is a chart that summarizes the physical features of our stream. We had a lot of glides in our stream. The percent glide was 58.8%. Pools were the least common, and that had a percentage of 8.9. We had 90% canopy cover, which meant that there were a lot of trees that covered the stream and not a lot of light got to the stream. And our total rapid habitat assessment score was 98, and the status of our stream was impaired. So this chart describes the chemistry at our stream, and our pH level was very basic with a score of 8.55. And the most common pH for streams are usually 6.5 to 8.5, so ours was on the edge of being too basic. And the total dissolved solids was 49%, and dissolved solids is the dissolved inorganic matter and organic matter that is in the stream, and that would explain our high amount of silt in the bottom of our stream. Our stream had a low salinity level of 0.03, and our stream actually had no nitrate levels.
So our assessment methods. First, we collected macroinvertebrates using a 0.33 meter dip net in 3 separate riffles and put them in ethanol. Then we collected physical habitat data for the stream and the surrounding areas, like Mackenzie just talked about the temperature, the pressure, water clarity, and the pH. We established our first wetted width, the latitudinal measurement, at the starting point of our assessment in order to figure out our 100 Thalweg measurements. Using these two, we were able to find the stream reach and the other 10 transects. Thalweg measurements are found by taking the first wetted width and dividing that number by 10. And this gives you the length upstream in between each cross-sectional depth. Methods continued. At each transect, we found the wetted width using a tape meter, channel depths using a meter stick, canopy cover at the right and left bank using a concave densiometer, and classified each transect as a pool, glide, or riffle. As we traveled upstream, my group also performed a Woolman pebble count for 100 pebbles at random using a metric ruler to determine their widths. And then lastly, we calculated the stream discharge, and this was done by timing how fast a bobber could travel 2 meters down our stream. And our results, based upon our assessment, we found that Crab Creek has very murky water, symbolizing an unclean environment. Our insect collection was very low because of such grimy conditions. The total score of Crab Creek was a 98, with 120 or higher being considered healthy. We also found that our turbidity was a 47, with a healthy stream being a 4 or less. Based on these two numbers, we considered Crab Creek to be impaired. My group believes that the railroad located on the right bank is the main cause of these conditions and the amount of inorganic matter that we found in our creek. And this is a table summarizing the rapid habitat assessment. And as you can see, our total score was a 98, which makes the status impaired. And our channel flow status was a 13. This is probably due to the rain that happened the night before we did our assessment. And then also our channel sinuosity was a 3, meaning that the section of the creek that we did was mostly straight and did not have any curves. And this is our macroinvertebrate table. We only collected 29 insects combined in our stream, most of which were filters and collectors. The most common macroinvertebrates that we found were net spinning caddisflies and non-biting midge. And lastly, this is a table summarizing the Virginia Stream Condition Index. Our HBI score was a 61.8, and our VSCI score was a 39.3. And these two numbers is reasons why our stream is impaired.
So reasons for impairment, we found tons and tons of glass in our stream, and the pieces kind of range from full bottles to just broken pieces. We also found old tires, broken road signs, and pieces of building, along with a full rug. And we think that a lot of the pieces that end up in the stream are due to the train kicking up fragments and then it falling down the bank and into the stream. But we also think a lot of like the building material or the tires and the rug came from the houses along our creek. So we think for our mitigation and restoration, we think the best way to fix the impairment in our stream is to conduct a stream cleanup, to go through and remove all the large debris that will be toxic to all of the living species in our stream, and it can interfere with the water flow as well. So thank you. So we want to thank the Office of Undergraduate Research and Scholarship for providing us a space for our team to present our work. We also want to thank the Radford Biology Department for providing us with the space and the equipment in order to conduct our authentic stream assessment. We also want to thank our TAs that were extra help to us during class and labs, and especially Angie Maddox for giving us our address to our stream location. We also want to thank the City of Christiansburg and the homeowners who let us on their property to do our stream assessment. Without them, we literally could not have done it. And last but not least, we want to thank Dr. Lau for answering our nonstop questions and for teaching us once clueless students how to confidently conduct a stream assessment. And this is our literature cited and questions. Does anyone have any questions? And thank you all for listening and hope you found it interesting.